without you reminding me that I'm not recording, is if I'm going to graph this guy, I look at the fact, what's the domain? Well, the domain is all real numbers. X can't be negative 2, which means I have a VA at x equal negative 2. I have the end behavior model is 2x over x, a quotient of the highest powers, which is 2. So I have an HA at y equal 2. So if I were to put that information here at negative 2, and I already have the graph drawn, at negative 2 I have a VA, and at positive 2 I have an HA. And you can see the graph nicely fits into that. We go after the zeros, just like we would any other time, and that's where the numerator equals 0, or 2x minus 1 equals 0, or x equals 1/2. It's multiplicity 1, which means that at x equals 1/2, the graph crosses the x-axis, and it looks like a line. And you can see that right here. Now, the reason why I go through this whole graphing bit and we lay the graph underneath, this is what I want you to notice. On rational functions, two things can happen, and two things cause the y values to change or not change. One thing is, of course, what we did for the polynomial functions, are the x-intercepts. Here, if I take a look at it, y is negative, then the graph crossed, and then y turned positive. So just like the polynomial functions, the x-intercepts will cause the graph to either touch or cross. Here's the other thing that happens. If you look at the asymptote, so here I have a VA. The VA happens to be multiplicity 1, which means that the arrows went in opposite directions. But the other thing that is of interest to us is, if I look at the left side of the VA, y is positive. If I look at the right side of the VA, y is negative. So the VA can cause the y values to change sign. Multiplicity 1 of a VA will cause the y values to change sign. By the way, multiplicity 2 of the VA means it will not. And that can be easily seen by our old furry friend. Y equals x squared, 1 over x squared. Here the VA is x equals 0 multiplicity 2. And on the left-hand side, y is positive, and on the right-hand side, y is also positive. So multiplicity 2 of a VA, there's no change. So the VAs can be considered to be critical numbers as well. So if I want to go down through, by the way, the answer from the graph, we want to, this says we want y less than or equal to 0. So this is going to be negative or equal to 0. Now negative or equal, this is where we are right here. That means from the graph, it's this little piece, which is going to be 0 to the x-intercept, and including the x-intercept, but not the VA. And from minus infinity, well, that's it. Because that's the only place that the graph is negative. Everything else, the graph is above the x-axis. So only this little piece right here, the y values are negative. So how might this operate if I didn't have a graph? Well, same way it does operate. First thing what I want is, it says I want y negative or equal to 0. This means it includes the x-intercepts. So the first thing I'm going to go after is the equal equation. These are the zeros. And that's where 2x minus 1 equals 0. X equals 1/2. This is multiplicity 1, and that means I have a change. Then I go after the not equal. This is the domain. X plus 2 can't be 0. It's the denominator. X can't be negative 2. It's also multiplicity 1. So you have a change. Because I am including the x-intercepts for the zeros, this is solid. For the VAs, this is an open. So as I pull my number line, I have a solid at 1/2 and a change. At negative 2, I have an open. It's multiplicity 1, change. And now I pull a test point, and guess what test point I'm going to pull? 0. And I'm going to draw a circle around it so I don't include it in my answer, which I so often do. So that if x equals 0, what do I have? 2 times 0 minus 1 over 0 plus 2. Well, that's negative. Change, positive. Change, positive. I want negative. It's right here. And this was wrong up here. It's negative 2. Well, what's my answer? My answer is not including negative 2 because it's a VA to 1/2 include. Which this should have been up here, negative 2. Because that was the VA, it wasn't 0. So I didn't have to care what the stupid thing looked like. All I had to know was the interaction with the x-axis.